Today's topic is acid-base equilibria. First, the definition of acid. What's a basic definition of acid? Acids are proton donors, where bases are proton acceptors. So, in Laurie and Bronston definition of acid and base, what is the definition of acid? A substance which will donate proton or H plus ion. We call that substance as an acid. And same way, what is a base? A substance which accept proton or gives H plus ion, we call that substance as a base. So if you have a reaction and you want to identify acid base, example HCl, which is a gas mixed in water, which is in a liquid state, from H3O positive ion and Cl negative ion. So if you want to identify the acid and the base, and this is a reversible reaction, means reverse can also happen. So if we check the forward reaction, first we have HCl, then it changes to Cl. So it donated proton as it donate proton according to the Bronston-Lowry definition. HCl is an acid. Same way water H2O, it changes into H3O. So if H2O changes through H3O, it means it accept proton. If something accept proton, according to Bronston-Lowry base, it is a definition, it is a base. So for forward reaction, HCl is an acid, whereas H2O is a base. And opposite will happen for a backward reaction, because reverse can also happen. H3O plus can lose its proton and change into H2O and HCl. So for a backward reaction, when we check H3O changing into H2O, so for a backward reaction, H3O is an acid. So we don't say as simply acid, we call that as a conjugate acid. In same way, Cl chloride ion is there, then it become HCl, so it accept proton. So if something accept proton, we call that as a base. But this is for reverse reaction, that's why we call that as a conjugate base. So each acid is linked to a conjugate base and each base is linked to a conjugate acid. Is it clear? Same way like H3O and HNO2, nitric acid and nitrous acid, when they react with each other, both are acid, but when in comparison, when we compare them, you can see HNO3 changes to NO3. So it donate proton, whereas HNO2 become H2NO2, it accept proton. So in terms of this reaction, HNO3 is acting like an acid, but HNO2 is acting like a base. How you can identify which one will lose, like example, because in this example, we have practically, if we have HNO3 and we dissolve or make an aqueous solution, so it will dissociate into H plus and NO3 minus. So it is an acid. If we have HNO2, when we dissolve or make an aqueous solution, it will form H plus and NO2 minus. This is also an acid. So both are acids, but when we mix them or make a solution, in that case, one will act like an acid and other will act like an alkali. How we can identify which substance will act like an acid and which will act like an alkali? So we have to check a value which is called Ka. Ka means dissociation constant of acid. So higher Ka value means more dissociation, it has greater tendency to lose proton. So when we want to write an equation or complete an equation which involves mixing of two acids, so the acid which is having the higher value of a Ka will tend to lose proton than the other one should gain proton. because sometimes you have a mixture of two acids and you have to complete the equation. So how you'll complete the equation? Using a data booklet, you will find the dissociation constant or Ka, and using the Ka dissociation constant, you can complete the equation. The one which acid which is having higher value of a dissociation constant has a greater tendency to lose proton. So in that mixture, the acid which is having higher value of a Ka refers to simple acid, and the other one in the mixture is refers to base, other substance or other acid. Is it clear, this part? So you have two acids, you have methanoic acid and you have butanoic acid. When you mix them together, both are acids in, because when you make a soluble solution, both tend to lose protons, both are acids. But if you have a mixture of two acids, the acid which is having higher value of a Ka will lose proton. So in this example, when we refer the data booklet, we will find methanoic acid is having a higher value of a Ka. So it will lose proton and the other acid will gain proton. Any doubt in this part? How we can work out the pH for strong acids and for weak acids. So simply how we can work out what is the meaning of pH. pH is equals to the negative log of hydrogen ion or concentration of hydrogen ion. So if you want to find the pH of a solution, it's minus log of hydrogen ion. And what it shows, negative log, it shows that if we have higher concentration of hydrogen ion, the pH of the solution will be smaller. So if you want to calculate the strong acid pH, as we know, the definition of a strong acids ionize completely. Acids are proton donors, but what is the meaning of strong acid? Strong acids ionized completely. So ionized completely, what's the meaning? Example, if you have 100 molecules of acid, out of 100, almost like 99 of them will dissociate into ion. So for acids, for strong acid, we can consider that the concentration of the acid is same as concentration of hydrogen ion. If it is monobasic acid, what's the meaning of monobasic? Like it tend to donate one proton. So if we have HCl and the concentration of HCl, example, if it's 0.1 mole per dm cube, HCl will dissociate into H plus ion. It is a reversible, but here the forward reaction is almost like completed because most of them are dissociated into ion and very few of them remain as a molecule. So what is our assumption? Whenever strong, practically there are some molecule, but our assumption that all of the molecule dissociate into ion. So the concentration of the acid is same as the concentration of hydrogen ion. And using this concentration of hydrogen ion, we can use the formula and find the pH of the solution. So example, what is the concentration of HCl with a, you can, and other way around, you if you know the concentration, if you know the pH, you can work out the concentration by taking antilog. So for HCl and nitric acid, HNO3, the example, the concentration of acid is same as the concentration of hydrogen ion, but not for sulfuric acid. Why not for sulfuric acid? Because sulfuric acid is H2SO4. So when it will dissociate into two proton and one sulfate. So what it means, it shows that the ratio is 1:2. So if it was 0.1, then hydrogen ion concentration will not be 0.1, the hydrogen ion concentration will be 0.2. That's in case of when you have sulfuric acid. But if you have monoprotic acids, like which are only giving out one proton, then the concentration of acid is considered same as the concentration of hydrogen ion is considered same as the concentration of acid. So in this example, like if we have original concentration, for example, if you have 0.1 mole HCl, so if you have 0.1 mole HCl, what will be the hydrogen ion concentration? We'll have the same hydrogen ion concentration, 0.1. We'll substitute in the formula and we'll get the pH. And whenever you're writing a pH, you should always use 2 decimal places. 2 decimal dp, not significant here. It means 2 decimal places. Like after point, you should use 2 digits. And other way around, using the pH, we can find the concentration of acid or hydrogen ion. So what we have to do, we just have to take antilog. As we know, pH is equals to minus log of hydrogen ion concentration. So if pH is given, like in this example, pH is given 1.3. So pH is 1.35 minus log of hydrogen ion. Then what we will do, or we can also simplify that log of hydrogen ion is equals to 1.35 and take antilog. Antilog will cancel this E. Log and antilog will cancel out. So we will know the hydrogen ion concentration, which is equals to 10 raised to power, because here it is log log is there. So that's why it's instead of E, we can use a power 10. Is it clear? This working of how to work out the pH of a strong acid, or using a pH, how you can work out the concentration of acid or hydrogen ion concentration. Any doubt in this part? Then what is ionic product of the water? Actually, what happened, as we know, water is H2O. So the water dissociate into ions. And what are the ions the water dissociate? If we have water molecule, H2O, which is in a liquid state. But the water molecule can dissociate into H plus and OH minus. When we write the Kc here, Kc is a product divided by reactant. So that will be hydrogen ion, the product hydroxide ion divided by H2O. This H2O, because this is a heterogeneous equilibria, so this is constant. So the concentration of a water multiplied by Kc, what we will call? We call that as Kw, or dissociation constant of water. You can see here H2O, this is fixed because amount of water, and multiply by Kc. So when you multiply these two, what you call that as equilibrium constant, or Kw. And this equilibrium constant having a certain value at, it vary with the temperature. So at 25 degrees centigrade or 298 Kelvin, the dissociation constant of the water is 1 exponent minus 14. Means the product of hydrogen ion and the product of hydroxide ion. If we have a water, what will be the product? It will be 1 into 10 power minus 14. This is called dissociation constant of water. What is the advantage of using this dissociation constant? So if I know the pH of a solution, using a pH, I can find hydrogen ion. And because all these acids and alkalis, they are aqueous, so means they are mixed in water or dissolved in water at 25 degrees centigrade. So when it's at 25 degrees centigrade, the product will always be 1 exponent minus 14. So if I know the hydrogen ion, I can find amount of hydroxide ion in the solution. But this product because this is endothermic reaction. So if we increase temperature, the value will increase. This is an endothermic, like if we supply more energy, equilibrium shifted towards right. So hydro, and as we know that the reversible reactions, the Kc or a Kp is only affected by changing the temperature. So it increases the value of dissociation of constant of water. But at 25, it is 1 exponent minus 14. How we can use this dissociation constant to work out the concentrations and pH of the solutions? For example, if you want to find a pH of a pure water, so if you want to calculate the pH of the pure water, as we know, water which is H2O dissociate into H plus and OH minus. And if we write the value for Kw, dissociation constant for water, which is a product of H and OH. Because the ratio between hydrogen and hydroxide ion is 1:1. So if we have X moles of hydrogen ion in the solution, we'll have X moles of hydroxide ion for a pure water. And dissociation constant is 1 into 10 to the power minus 14. And hydrogen ion concentration is X, hydroxide ion concentration is X. So this will be X squared is equals to 1 exponent minus 14, or X is equals to 1 into 10 to the power minus 7. That's the hydrogen ion concentration. And using this hydrogen ion concentration, we can find a pH. As we know, pH is equals to minus log of hydrogen ion concentration. So minus log of hydrogen ion concentration is 1 into 10 to the power minus 7. So when you substitute, what you will find the pH is equals to 7. But this is at 25. When the water is at 25 degrees centigrade, the pH of the neutral water, the pure water, it will be 7. But for example, if the temperature changes, like the temperature of the water is not 25, in this example, the pH of the temperature is 50. And at 50, the dissociation constant is different, like it is 5.4. 7 into 10 to the power minus 14. So what you can do, you can also work out for a pure water, amount of hydrogen ion and hydroxide ion will be same. So if we say we have X moles of hydrogen ion in the solution, so we should have X moles of hydroxide ion. And so the Kw is equals to concentration of hydrogen ion and hydroxide ion. Kw is given, you can see the value of a Kw, dissociation constant, and X square, and when we solve, we'll get X. Using this X is actually a concentration of hydrogen ion. So you'll use the formula pH is equals to minus log of hydrogen ion, we'll get 6.6. So what does it mean? 6.6, still this water is neutral. 6.6 does not mean it is acidic. Why 6.6 does not mean it is acidic? As we know, studied in O levels, you studied the pH scale, that when you have a pH scale, it ranges from 0 to 14, and 7 you say it's a neutral, and below 7 you call acidic, and above 7 are known as alkaline. So 6.6 is here. But why 6.6 is not considered as acidic when the temperature is 50? Because this pH scale also changes or vary with temperature. At 25 degrees, the range is from 0 to 14. But at 50 degrees, actually the range is not from 0 to 14. The range is only from 0 to 13.2. So what is the center? Actually, the center is 6.6. So that's why it will be neutral at 6.6, acidic below 6.6, and alkaline above 6.6. So is it clear? The dissociation constant, and we have the equal amount of hydrogen and hydroxide ion. That's why the water is also a neutral water. So it does not mean that if you have a pure water and its temperature and its pH is less than 7 or more than 7, it is acidic or alkaline. It depends on the temperature at which you are measuring the pH. Any doubt in this part? Is it clear? The dissociation constant of the water and how the pH of a pure water changes as the temperature increases. Then how we can calculate the pH of a weak acid, as strong acids we have done, or for first for strong base, how to calculate the pH of a strong base. So for bases, proton acceptor or OH ion donor. So for base, what we will do first, for strong base, such as sodium hydroxide is there, potassium hydroxide. So it will dissociate completely. So as it will dissociate completely, like example, you have sodium hydroxide. So if you have sodium hydroxide or NaOH, this NaOH or sodium hydroxide, it's a strong base. So strong base, it will ionize completely, dissociate into H plus and OH minus. So what is the concentration of NaOH? Same is the concentration of sodium and same is the concentration of hydroxide. So using the concentration of hydroxide and dissociation constant of the water, because all acids and alkalis are aqueous, so I can use the dissociation constant of a water. After knowing the hydroxide ion concentration from the concentration of alkali, and dissociation constant is fixed according to a temperature at certain temperature, but at 25 it is 1 exponent minus 14, and we are solving all these questions assuming that the temperature is 25 or 298 Kelvin. So we can find hydrogen ion, and using hydrogen ion we can find the pH, which is equals to minus log of hydrogen ion concentration. So you can see what is the pH of a strong base of concentration 0.1 molar. 0.1 molar means 0.1 mole per dm cube. Assume that it's a complete dissociation. So as we know, Kw is hydrogen ion plus hydroxide ion. So Kw is 1 exponent minus 14. And we know the hydroxide ion, that's equal to same as the concentration of alkali. So we can find the concentration of hydrogen ion, substitute in the formula, and we'll get the pH of the strong base. So this is how we calculate the pH for a strong base. For strong acids, directly we will know the hydrogen ion concentration. So using the hydrogen ion concentration, we will get the pH. But for strong base, first we will have hydroxide ion concentration, and using the hydroxide ion concentration, we will find the hydrogen ion concentration by dissociation constant of water, and using a dissociation constant of water and hydroxide will get hydrogen ion. Using hydrogen ion we'll get the pH. What if it is a weak acid? So weak acids ionize partially, does not ionize completely. So for weak acids, we will use the value for dissociation constant, which is also called Ka, because for weak acid, like such as ethanoic acid, methanoic acid, these acids ionize partially. Example, if you have ethanoic acid, this ethanoic acid will dissociate into ethanoate ion and hydrogen ion. So if originally, like example, if this concentration is A, this will be 0 and 0 initially. But at equilibrium, when we dissolve, So if this concentration is X, this one is X, so this will be A minus X. In this example, because if it was a strong, we assume that actually what is the original concentration, same with the concentration of hydrogen for a strong acid. But for weak acid, we cannot consider that. Why? Because it's not possible. Weak acids ionize partially. Then we will use the formula for Ka, the dissociation constant, which is product divided by reactant for, so the ions CH3COO, concentration of acetate ion in this example, concentration of hydrogen ion divided by concentration of original concentration of weak acid. Sorry, concentration of weak acid at equilibrium. So we will, what we'll substitute, Ka is equals to, this will be X, this will be X, this will be A minus X. But what we assume because the value of X, it's a weak acid, so it ionizes partially. So value of X is very small. So when I subtract from the original concentration, it will not make much difference. So we can neglect, we can assume that A minus X is approximately equal to A. Why? Because we assume X is very small. So dissociation constant is equals to X square by A. So if we know the dissociation constant, we know the original concentration of acid, so we can work out the hydrogen ion concentration, and using hydrogen ion concentration, we will work out the pH. So in this question, like first we have to write an equation for dissociation of propanoic acid. So we have propanoic acid, it will dissociate into H plus and propanoate ion. And when we write K, it's a product divided by reactant. So we'll get this K. What is pK? What's the meaning of pK? As we know, like pH is equals to minus log of hydrogen ion. So pKa is equals to minus log of Ka. pH is equals to minus log of hydrogen ion, where pK is equals to minus log of dissociation constant of acid. Is it clear how we will work out the hydrogen ion concentration for weak acids, and using hydrogen ion concentration, we can find the pH. Any doubt in this part? pKa and pH are not same, but the idea is same. Like example, as pH, pH is refers to minus log of hydrogen ion concentration. So pKa refers to minus log of dissociation constant of acid. This is how we calculate pKa. Reason, like example, because these hydrogen ion concentrations are in exponent. So when I take a log, I will get a small number, so easy to denote or represent. Like if it is written 1 into 10 to the power minus 3 or minus 13. So it is difficult to recognize whether the solution is acid or alkaline. So what we do, if it is difficult to recognize whether it is an acid or alkali, so we simply find a pH. And using a pH, because small scale or small numbers are there, so easy to identify whether a substance is acid or alkaline. Same way, because dissociation constants are in exponent, you can see here 1.7 exponent minus 5. So in just a way to represent in a number, a simple number, instead of Ka, we can also write Pk. Is it clear? So if you want to calculate the pH of a weak acid, what is our assumption here? We assume that the hydrogen ion, the other ion concentrations are same ratio according to 1:1, and the initial concentration of the acid and equilibrium concentration are equal. We neglect that it's very small dissociation, negligible dissociation is there. So you can see in this question, the pH of the solution, is 0.01. We have to calculate what is the pH of a solution of 0.01 molar ethanoic acid with the value of a Ka 1.7 exponent minus 5. So first you will write equation for ethanoic acid. As we know, ethanoic acid is CH3COOH. So it will dissociate into CH3COO minus and H plus. And what is the original concentration? Initial concentration or original concentration? 0.01. So this will be 0 and 0. What is the equilibrium concentration when there's a balance? If this was X, this is X, this will be 0.01 minus X. And then I'll write the formula for Ka. K for this product divided by reactant. So it will be CH3COO concentration, acetate ion concentration, hydrogen ion concentration divided by ethanoic acid concentration at equilibrium. And Ka is given in the question, so that's 1.7 into 10 to the power minus 5. Concentration of ethanoic ion is X, concentration of hydrogen ion is also X, and this one is 0.01 minus X. But what is our assumption here? That 0.01 minus X is approximately equal to 0.01. It's a very small, X is a very small number. So 1.7 exponent minus 5 is equals to X squared divided by 0.01. The 0.01 is divided, other side it will be multiplied, and to remove this square you will take a root. So using this you will get the value of X. And what's the value of X? Value of X is equals to 4.12 into 10 to the power minus 4. And X is actually equal to the concentration of hydrogen ion. So using the value of X, which is same as the concentration of hydrogen ion, you can find pH equals to minus log of hydrogen ion. So hydrogen ion you will substitute and you will get the pH, which is 3.38. Is it clear? And these all, even dissociation constant value may change, but it's all assumption that all are done at, or all are calculated at 25 degrees centigrade or 298 Kelvin. Same way, what is the concentration of the propanoic acid if the pH is given? So using the pH, you can also work out the concentration. How to work out a concentration? So propanoic acid, so this is the equilibria. First, always write the equation. This is the equilibria for, and if we have a pH, so using a pH, we can find hydrogen ion concentration. As we know, pH is equals to minus log of hydrogen ion concentration. So pH is 3.52 minus log of hydrogen ion, and then take anti-log and get the hydrogen ion concentration, which is 0.000302 mole per dm cube. And as we know, because our assumption is that the dissociate here, the ratio of hydrogen ion and propanoid ion is 1:1. So if this is the concentration of hydrogen ion, same is the concentration of propanoid ion. So when we write the equation for this dissociation, so hydrogen ion dissociation concentration at equilibrium is same as propanoid ion dissociation. So we have Ka, that's given in the question, 1.35 exponent minus 5. We have hydrogen ion, we have propanoid ion, because using a pH we worked out, so we can find the original concentration of this acid. Is it clear how it is done? Any doubt till now? Then working out the pH of a weak acid at half equivalence point. What's the meaning of the half equivalence point? It is when basically when half of the acid neutralizes the alkali, we call that as half equivalence point. And what is the meaning of half equivalence point? Like example, if we have, say, weak acid is there, say CH3COOH, weak acid. It is reacting with sodium hydroxide. When it reacts with sodium hydroxide, this will result in a formation of CH3CONA plus H2O, the product, salt and water. Sodium ethanoate will be there and the product water will be there as well. Half equivalence point, what is the meaning of half equivalence point? Means when half of the acid is used up. Like if you have 2 moles of acid, out of 2, 1 mole of acid is used up. And at half equivalence point, actually what happened, the concentration of the acid is same as the concentration of its salt at half equivalence point. Because like example, if I say I have 10 moles of weak acid, and out of 10 at half equivalence point, 5 will react. So if out of 10, if 5 will react, so 5 will form the product. And the product is a salt, which will result in ion. So at half equivalence point, the concentration of acid is same as the concentration of the salt which is formed. Or we can also say at half equivalence point, when we have a half equivalence point, the concentration of, like if you have CH3COOH, it will dissociate into CH3COO plus H plus. So at half equivalence point, the concentration of acid and the concentration of ion, which is formed due to a reaction of acid, will be same. So their concentration, when I write the formula for Ka, the concentration of acid and concentration of the ion which is formed due to acid will be same. So they cancel out. So at half equivalence point, we can say hydrogen ion concentration is equals to Ka, or we can also say if we take minus log of hydrogen ion or minus log of K, we can also say in at half equivalence point, the pH of the solution is equals to pK at half equivalence point. Is it clear this idea how the pH and so if we know the pK, we can find the pH, or if we know the pH, we can find the pK. So this is a practical way of finding the dissociation constant. You use a half equivalence point. Half equivalence point means when half of the acid is reacted, so it will form the product, and the concentration of the acid